Hello, this is Mrs. Pullen, Unit 4, Day 6, Rational Equations. So a rational equation involves algebraic fractions, and you'll know it's an algebraic equation because there's an equal sign. And there are multiple methods that we can use, but I'm going to only do one right now, and that I call the LCD method. What we're going to do is we're going to find the LCD of all three terms in this case, so any terms on both sides of the equation, and then we're going to multiply each term by the LCD and reduce. Okay, let's see it in action. So what is the LCD for 3, 12, and 4? That would be 12. 3 goes into 12 evenly, 12 goes into 12 evenly, and 4 goes into 12 evenly. Let's rewrite the original equation so you can see what's happening. And I'm going to switch colors, and I'm going to multiply each term on both sides of the equation by 12. I'm going to switch colors again, and then I'm going to reduce. 3 goes into 12 4 times, 12 goes into 12 once, and 4 goes into 12 3 times. Remember, it's 3 times 9 that you're left with, 4 times A. So let's rewrite the expressions. 3 times 9 is 27. Notice you no longer have a denominator using this method. So we're going to solve this as a linear equation because there's no a squareds. We're going to combine like terms and solve for A. With this type of method, you have to check the original equation. So we're going to restate the original equation. And wherever you see an A, you're going to replace it with a 3. So this becomes 1 plus 15 over 12, which is the same thing as 1 plus 15 over 12 reduces to 5 over 4. And if you add the 1 plus 5/4 in your calculator, you're going to get 9/4. So that matches. And what that means is that 3 is our solution, and we really should put it in solution brackets. Uh-oh. I overdid my brackets. Let's fix that. Better? Okay, let's go to another problem. Let's do example 6. It's a little bit more complicated. And what we're going to do is find the factor first so we can find the LCD. So the LCD is what each of these denominators on both sides of the equation can go into evenly. So there are 3 denominators that we have to look at. And so what could each of these go into evenly? X minus 6 times x minus 2. So let's write this on the side. I'm going to switch colors, and for each term I'm going to multiply it by x minus 6 times x minus 2. I'm going to reduce common terms. I'm left with x minus 2 plus x times x minus 6. Be careful not to lose that x here, is equal to 4. I'm going to distribute that x in that second term. Make sure you distribute that x here. Notice I now have a quadratic equation. How do I know I have a quadratic equation? You see that x squared? I'm going to combine like terms on the same sides of the equal sign. So I get x squared minus 5x minus 2 is equal to 4. I'm still not in standard form. A standard form of a quadratic equation is ax squared plus bx plus c equals 0. So what that means is I have to bring that 4 over to the other side by subtracting 4 from both sides of the equation. I can now factor. And set each linear factor equal to 0. We're almost done, but we're not done quite yet, because what we have to do is we have to check both solutions, both the 6 and the -1 in the original equation. So when we check in the original equation, let's first check 6. We get 1 over 6 minus 6. And right away we have an equation, because this is the denominator of that first one is going to be 0. It's going to be undefined. So it's not going to work. So we know that 6, let me switch colors, is going to reject. So now we have to check x is equal to -1. Just be careful when you check, because sometimes students make mistakes in the check and they reject something they shouldn't. So remember to square your negative. Well, that's a plus. Hold on. Let me get that eraser out. Whoop. Guess I didn't do a good job getting that eraser out. So when you enter this in the calculator, it's going to be -3 plus 7 over 21 is equal to 4 over 21. Is that true? And we could see that that is true. So notice that in this case, the answer is simply -1. In any case, I hope this video helped.